Hi, my name is Nick, and I'm a graduate student at the Institute of Optics, and I'm here today to tell you about lasers and laser communications. So here we have a laser demo, which is a favorite in our community outreach events, and I'm here to tell you a little bit more about how the laser works and what you can do with it. So in front of me, we have a bunch of different components. We have a laser right here, which generates our light. We have a detector over here, which has a collimated beam focused on it. And we have a speaker. And we can use this demonstration to transmit sound information with laser light. First, let's talk about the laser. Right here we have a circuit which prepares the electrical energy over here to enter the gain medium in the light bulb over here. This gain medium converts electrical energy into light energy or photons. And the photons bounce back and forth between these two mirrors which form the cavity of the laser. And as they're doing that, as they go through the gain medium, the photons become coherent with one another so that they go back and forth together. And this makes it so that the output of the laser is highly directional, single color, and coherent. Now let's talk about the detector. Over here, we have a silicon detector which turns light signal into electrical signal. And we can do all sorts of different things with this. But in this case, we'll take the beam coming out of our laser and we'll align our detector with the laser beam and run it into a speaker. And we'll see what sorts of fun things we can do with that. Finally, let's talk about the demo. First question we ask ourselves is, can we make sound by blocking light? That's an interesting question. So we can take an ordinary comb and do this. When I run the comb across my fingers, the comb will tend to bump my fingers up and down as I move along, as you might be familiar with. But as I run the comb in front of my eye, it also does the same thing with the light. So if I put it in front of the laser, it's also going to modulate the light up and down, up and down, up and down. And by changing the speed at which I move the comb through the laser, I can generate a frequency this way that my ears can interpret because I have my detector hooked up to a speaker. So let's try it out. So if I go slowly, it'd be barely audible. If I go quickly, it becomes more of a sound. Pretty fun. So now that we've seen one way that we can turn blocking light into generating sound, is there another way that we can do that? So we just put the comb into the laser beam and we selectively blocked, turned on and off the laser beam as it appeared on the detector over here. So instead of doing that, we can turn the laser on and off directly by running a cable into it and connecting a device that can generate music via electrical signal. So when I turn that on, you can hear the music coming out of the speaker because we're turning the electrical signal into an optical signal, which then generates the music and comes out the speaker on the other side when it's converted by the detector. And in this way, we can use light to transmit all sorts of different types of information. This is similar to the sort of optical fiber communication, which is used to send internet information. This could also be used for free space communication. And this general principle is just one example of how optics plays a very important role in our day-to-day lives. All right, everyone, my name is Nick. Thanks so much for watching. If you like this video, feel free to subscribe or like us below. And now that you've stuck around for the whole video, we have a bonus tip for you. If you like, you can actually use this setup to DJ your music. Wait for it. Or at least you can try. But that's all I got. See you next time.